Chapter 4, Section 3 is entitled Properties of Exponents. We're going to look at using exponents in different situations outside them being isolated, or zero exponents, or just negative exponents, or in a order of operations type question. We're actually going to be looking at using them in other situations. So in the first one, number 1, part A, they're asking us to multiply and to write the product as 1 power. Now, an option for us here is to actually solve this question out. Change it to numbers, work it through, do the multiplication, and then figure out what that multiplication problem would yield to us as a question in terms of a power, or something written with an exponent. That's really the long way home, though. There's other ways to do this question. One of the basic rules of exponents here is about when we have a problem that's multiplication with the same bases. Now, in case you've forgotten, the base is the big number in the question. And as you can see looking at this question, the bases both happen to be 6. What this property tells us here is that when we're doing this multiplication problem and we have the same bases, all we have to do to simplify is to actually add the exponents. Now, that might seem a little bit strange to you that we're doing a multiplication problem and we're adding the exponents, but that is indeed what the property tells us to do. So since this is 6 to the 6th times 6 to the 3rd, I'm going to add my exponents being 6 and 3, and when I add that 6 and 3 together, that's going to give me 9, and so simplified, this is 6 to the 9th. Notice that the directions ask me to write the product as a power. So if I actually do 6 to the 9th, or if I actually do the problem and multiply it, I really haven't done what they've asked me to do. All I've done is, in essence, done extra work, because they weren't asking me to compute that. They were just asking me to write this as a power. Let's look at B. N to the 5th times n to the 7th. So the rule again says when we have multiplication problem and the same bases, both being n in this question, we're just going to go ahead and add those exponents. So this is 5 plus 7, and that's going to change into 12. So n to the 5th times n to the 7th is equal to n to the 12th. 2 to the 5th times 2. Now this one is a little bit tricky because some people look at that 2 part and say, well, that doesn't have an exponent, so it's the same as what it starts off as. Not exactly. 2 would be 2 to the 1st power. All right, because of course 2 to the 1st power would be 2 in a multiplication problem one time. Well, I'm not multiplying it by anything, that's how I would just get 2. So here, I'm going to add those exponents, the 5 that they gave us and the 1 that we figured out, and that's going to go together to make 2 to the 6. And then finally, we'll wrap up with 24 to the 4th times 24 to the 4th. Now, I really don't want to be messing around with 24 to the 4th and figuring that out, because that's really quickly going to get rather large on a calculator. But if I'm just figuring it out with the exponents, I'm just adding my 4 and 4 together to get 8, and I realize this is 24 to the 8th. So now we go from number 1 where we were multiplying to number 2 where we are dividing. So it should come as no surprise to us as when we were multiplying we actually added the exponents. Say now that when we're going to divide, we're going to, of course, subtract the exponents. And again, this only works if you have the same base. If you have different bases, the stuff we're doing doesn't apply here. But when those big numbers, the bases are the same, you can do exactly what we're doing here. So with 7 to the 5th divided by 7 to the 3rd, remember a fraction bar means division. With 7 to the 5th divided by 7 to the 3rd, we're going to go ahead and subtract those exponents. So 5 minus 3 there, which is of course going to change into 2. And so this is now 7 to the 2nd power. With the B question, x to the 10th over x to the 9th. So I'm going to go ahead and take those and again subtract the exponents. Why? Because the bases are the same. So this is going to change into something that's 10 minus 9. 10 minus 9, that's of course going to change into a 1. So that would be like x to the 1st or just plain old x. Just in the same way that a minute ago, when we had, I believe it was a 2 to the 1st, we just wrote that as 2. Same thing here, x to the 1st can just be written as x. Now the last property they teach us here is about raising a power to another power. So they're going to give us a power, something with an exponent, and then they're going to throw another exponent on it. When you raise a power to a power, all you have to do is multiply those exponents together to figure out what this simplifies to be. Again, as you can see, we're going to see some negatives introduced here, and generally we don't do much with those negatives. We flip them to the other side of the fraction and make them positive like we saw in an earlier presentation there. Obviously, this also doesn't require the same bases because we only have one base to begin with, because it's two exponents, not two different powers. So this is A is 5 to the 4th being raised to the 2nd power. So that means we're going to go ahead and multiply those exponents together. We're going to multiply together the 4 and the 2 there, and that's going to give me 8. So that's 5 to the 8th power. B, you've got 6 to the 7th being raised to the 9th power. So again, when you have those two powers going together, we're going to multiply those together, and that's the same as 6 to the 63rd. Now, this is where things are going to start getting messy, because in question C there, now they're actually going to throw a negative at us. So that rule does not change that. The exponents there being 12 and negative 3, that's going to give me negative 36. So this is 2 over 3 being raised to the negative 36th power. And again, generally this answer is not acceptable. What we would do is we want to get rid of it the same way we've already learned how. So I'm going to put 2/3 to the negative 36th power over 1, and then I'm going to flip that to the other side of the fraction, which is going to make this exponent go positive. So this is 1 over 2/3 being raised to the 36th power, which is a little bit better of a mathematically proper answer anyway, as we would expect. D, 17 to the 2nd being raised to the negative 20th power. So again, this is all about me multiplying those exponents together. 2 times negative 20 is going to make negative 40. So this is 17 to the negative 40th power. And again, we would not generally write that like that. We would put this over 1, and again, flip this to the other side of the fraction, which is going to have the effect of making that go positive. The top going vacant, so this is 1 over 17 to the 40th. All right, so let's put those rules to good use here in the check it out, the concluding examples for this presentation. 4 to the 2nd times 4 to the 4th, and they're asking us to write our answer as 1 power. So again, as we recall, when we have the same bases and it's being set up as a multiplication problem, we're just going to go ahead and add those exponents together. So since those exponents are 2 and 4, I'm going to add my 2 and 4 together, and that's going to give me 6. So this is 4 to the 6th. Number 2, 9 to the 9th divided by 9 to the 2nd. Again, hopefully you remember that when we divide and the bases are the same, we subtract the exponents. So this is 9 minus 2 is how I'm going to get to the solution here. 9 minus 2, of course, changes into 7. So this is 9 to the 7th power. And then the last one, we're raising a power to a power. 5 to the negative 2nd being raised to the negative 3rd power. And again, hopefully remember here when we do this type of question, what we do is we go ahead and multiply those exponents together. So we're going to multiply together the negative 2 and the negative 3. And that is even better for us because those two negatives are going to make a positive, which means I'm not going to have to deal with the negative exponent fixing that. And we end up with 5 to the 6th.